Hello everyone, in this video we shall be learning about map entered variable technique. The contents of the video are why is MEV used, two examples of MEV and implementation of Boolean expression using 8:1 multiplexer using MEV. So why is MEV used? As we all know, K-map is the best manual technique for the simplification of Boolean expressions. But due to difficulty in managing K-map exceeding 4 variables, like 5 or 6 variables, we have this technique called map entered variable. MEV is used to increase the effective size of the K-map. It allows smaller map to handle large number of variables. Now we should be looking at the first example. We have y is equal to f of a, b, c, d is equal to summation of minterms 2, 3, 4, 5, 6, 13, 15 plus the don't care terms 8, 9, 10 and 11. The first step is to construct a truth table for the given function. Since we have 4 variables a, b, c and d, we have 16 combinations ranging from 0 to 15. We enter the given minterms and the don't care terms into the truth table. So we have 2, 3, 4, 5, 6, 13 and 15 and the don't care terms 8, 9, 10 and 11. The next step is to obtain our map entered variable. In order to obtain map entered variable, we group the uh, rows of the truth table into two and then we compare the value of f in these two rows. Here we have 0 and 0. So this means that irrespective of the value of d, our function is 0. So our map entered variable will be 0. Next we have 1 and 1. This means that irrespective of the value of d, our function is going to be 1. So this gives us the map entered variable to be 1. Next we have 1 and 1 which gives MEV to be 1. Next we have function as 0, 1 and 0. Here we can observe that when d is 0, our function is 1 and when d is 1, our function is 0. So we can write the map entered variable to be d complement since the function is the complement of the value of d. Next we have two don't care terms. This means that irrespective of the value of d, our function is going to be don't care. So this gives us the map entered variable to be don't care. Next we have don't care and don't care, which again gives us the map entered variable to be as don't care. Next we have 0 and 1. Here we can observe that when d is 0, f is 0 and when d is 1, f is also 1. We can see that f is exactly the value of d, so which gives us the map entered variable to be d. Here we have 0 and 1 which is same as the values of d, so we have map entered variable to be d. The next step is to plot all the MEV terms into a K-map. So here we have plotted all the zeros, ones, don't cares, D complement and D terms into one K-map. In the next K-map, we are grouping the ones with the other ones and don't cares. We can see that this one can be grouped with this don't care term, which gives us the term B complement C, plus this one is isolated, which gives us the term A complement B C complement. This can be taken as MS1. In the subsequent K-maps, we replace all the ones by don't cares and we group only alike MEV terms. In this K-map, we are grouping the D terms with the don't cares. We can observe that we have replaced one by don't care. So this grouping gives us a quad which gives us the term AD which can be taken as MS2. In the next map, we are grouped D complement term. This D complement can be paired with this don't care term which gives us the term A complement B and D complement which can be taken as MS3. So our final answer will be the summation of MS1, MS2 and MS3. So our final expression is B complement C plus A complement B C complement plus AD plus A complement B D complement. This is the simplified Boolean expression. This is the first kind of problem we have. Moving on to the second example, here we have Z of A, B, C, D, E, F, G is equal to summation of minterms 1, 3, 6, 8, 13 plus EM11 plus EM15 plus FM0 plus GM5 plus GM9 plus don't care terms 2, 10 and 14. In this problem, we have more than one MAV variables. So to proceed with this kind of problem, we first plot all the entries into a K-map. As we can see, we have plotted all the minterms, that is 1, 3, 6, 8, 13, and the E terms in 15 and 11 minterm place, and we have plotted the F variable in the place of M0 and G in the place of 5 and 9, and the don't care terms 2, 10 and 14. The next step is to group ones with the other ones and don't cares. We can see that this one can be paired with this one, which gives us the term A complement B complement D. We can group this one with this don't care, which gives us a pair A B complement D complement, plus these four terms can be grouped together, which gives us the term C D complement, and this one is isolated, which gives us the term A B C complement D. Next, we replace all the ones by don't cares and group only alike MAV terms. So we have one K-map for each variable. In the first K-map, we can see that we have only plotted the E terms and replaced all the ones by don't cares. So we can see that we can group these two E terms with these two don't cares, which gives us a quad, which gives us the term ACE, A, C and E, which is MS1. In the next K-map, we have plotted the F terms and replaced all the ones by don't cares. We can see that this F term can be grouped with these three don't cares, which gives us a quad A complement B complement, A complement B complement and F, which is MS2. In the next K-map, we have plotted the G terms and we have grouped these two G terms with these two don't cares, which gives us a quad C complement D G. Our final answer will be the addition of MS0, MS1, MS2 and MS3 terms, which gives us Z is equal to A complement B complement D plus A B complement D complement plus C D complement plus A B C complement D plus A C E plus A complement B complement F plus C complement D G. Moving on to the application of MEV, MEV can be used in the problems related to multiplexers. For example, here we have simplify the given 4 variable expression using MEV and realize the same using 8:1 multiplexer. We all know that for 8:1 multiplexer, we have only 3 select inputs. So we need to simplify the given 4 variable expression into 3 variable expression with the help of MEV. So we have the question f of a, b, c, d is equal to summation of minterms 4, 2, 10, 14, 15 plus the don't care terms 0 and 8. As we have seen in the previous problems, our first step is to construct a truth table. Since we have 4 variables a, b, c, d, we have 16 combinations ranging from 0 to 15, and we enter the given function. We have don't care 0, 0, 0, 1, 0, 0, 1, don't care 0, 1, 0, 0, 0, 1, 1. Our next step is to select a map entered variable. In this problem, I'm selecting D as my map entered variable. In order to obtain the map entered variable, we need to compare these two rows of a function. We have don't care and 0. This don't care can be considered as 0. So 0 and 0 gives us the map entered variable to be 0. This means that irrespective of the value of D, our function is going to be 0. That's why we write the map entered variable to be 0. In the next one, we have 0 and 0, which gives us the map entered variable to be 0. In the next one, we have 1 and 0. Here we need to look into the values of D. When D is 0, f is 1, and when D is 1, f is 0. We can observe that f is the complement of the value of D. So we have a map entered variable to be D complement. Next we have 0 and 1. Here we can see that when D is 0, f is 0, and when D is 1, f is 1. So we can write the map entered variable to be D. Next we have don't care and 0. Here we can consider this don't care to be 0. So 0 and 0 gives us 0. Next we have 1 and 0. We can observe that when D is 0, f is 1, and when D is 1, f is 0. So we can write a map entered variable to be D complement. Next we have 0 and 0, which gives us 0 as the MEV. Next we have 1 and 1. Here we can see that irrespective of the value of D, our function is going to be 1. So we write the map entered variable to be 1. Now the obtained map entered variable values can be taken as the inputs for multiplexer, which is I0, I1, I2, I3, I4, I5, I6, and I7. Here we can see the implementation of the given Boolean expression using multiplexer. We have the three select inputs A, B, C, and we have one output Y, and we have 8 inputs ranging from I0 to I7. As we saw in the previous slide, I0, I1, I4, and I6 have the value 0. So we are connecting I0, I1, I4, and I6 to ground. And I7 has the value 1. So we are connecting I7 to VCC. And we have I2 and I5 as D complement. So we are connecting I2 and I5 to D complement. And I3 is connected to D. This is how we implement the given Boolean expression using multiplexer with the help of MEV. In this video, we have learned the purpose of MEV and two examples of MEV, and we have seen how to implement the given 4-variable expression using 8:1 multiplexer with the help of MEV. Thank you for watching.